All right, so now, this is the second hour. I know we don't have to pretend to be excited to be here, right? Because everyone actually is. So let's see. So we're gonna start this out. So class.
Yes.
That was weak sauce right there. At least pretend to like you want to be here then. Some Mario, can you believe this guy? Yeah. Anyway, all right. So with you and your group, your homies in your group right now, use the information we went through on Friday. Describe, explain what you see in this right here. It is a position over time, so this is a velocity graph. So with your people in your group, let's talk about it. And go. Maybe the other two. You guys are doing a lot of communication here. Oh, really a lot of communication. Come on now. Talk about it. Wow.
Did we write it?
Yeah. Right. You guys are describing this. We went over it on Friday, and look at your notes from Friday of how we describe these things. Really sad. I had my last class, a lot of people just not writing it down. I'm like, this is the answers I'm looking for. Huh? Of what? Oh, okay. I'll share with you. All right. Let's see what we got. Someone want to tell me what I have here? Explain what I have. Roberto, tell me something. What's negative? The what? Not negative speed. We can't have negative speed. What is the graph of? Okay, position over time. What is position over time? I keep looking at him. You got the notes too. Did someone forget to write in the notes? this? Okay, what is that? Okay, but this is, but what is V? Velocity! Thank you, loud and clear. This is what type of graph? A velocity graph. Okay, a velocity graph, position over time. He said it is going down, right? So the slope of this is going down, so that's negative. So it means it has a negative velocity. Very good. What about that shape of that line? This only goes for people that wrote the stuff down because we had a vocabulary word last week, which actually explained this one. Concave down. Very good. Concave down. Concave down. So yes, that is a good word to write down, especially if you don't have anything written down. It is concave down. So from right here, it's actually going down. Now, is it a straight line? No, it's not a straight line. So what do we know about the velocity? Is it constant? It's not constant. So if it's not constant, that means what's happening? If it's not constant, okay, the velocity is not constant. Where's my truck? Here it is. Got my truck right here. Ford Ranger. Okay. If the velocity is not constant, that means it's doing what? What are we about? What are you doing? It's speeding up and okay. I'm doing a velocity of 25 miles per hour. Okay. I'm currently doing 25 miles per hour. And then I'm doing 25 miles per hour. Then I'm doing 25 miles an hour. And I'm still doing 25 miles an hour. So that velocity is positive. It is 25. Is it changing? No, velocity is not changing. So that means a constant velocity, 25 miles an hour, is going to stay 25 miles an hour. That is a straight line. But if the line is curving, that means I am either increasing or decreasing my speed. So that means if I'm increasing speed, I am, another word, we've talked about it a bunch. Very good. I'm accelerating. So acceleration. So that means that if this line is curved, it is either accelerating or decelerating. If it's curved, it is accelerating or decelerating. If I'm looking right here, it looks kind of constant. So my slope looks like it's about a 0 here, but then as it keeps going down, keeps changing. Does that make sense? All right, so let's look at this next one. This next one, the position over time. What can I say about that position over time? It is negative. It has a negative. Very good, negative velocity. So it's a negative velocity. Is it a straight line? It's not a straight line. Okay, it's not a straight line. So that means if it's not straight, what does it mean? It's accelerating, right? Acceleration is happening there. Now, what about the shape of the line? Shape of the line. Back to that vocabulary word. Huh? It's concave. Not down. It's up. Concave up. Now, do you see that it's concave up? Now, okay, so don't get me in trouble for this. I already got in trouble once. I'm gonna throw up some gang signs right now. Okay, so calm down. This is a math game. This is a parabola. It's a parabola, right? Okay, if it's a parabola, this is facing up. It's opening up. It is concave up. Okay, so it's concave up. This is also a parabola. This one is going to be concave down. Concave down. It's opening down. I'm going to put these two together. So I have a concave up and a concave down at the same time. So as they go together right here at my fingers. So if I'm looking at this one right here, at the very vertex of my right hand, it is accelerating, it's going up, it's going up, it's going up, but now it changes to start going down, 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 down. What? You just took notes on that?
Yeah.
Hey, awesome. Okay, so now in that class, you're going to be throwing up signs. You're going to be like, oh. And as my fingers come together, that's going to be my point of inflection. That's where it's actually going to change concavity. So that change in concavity is actually where my acceleration is equal to 0. So it changes there. All right, so there you go. Hopefully that was somewhat educational for people that are awake. Others that are wait for me to just stop talking. Not implying anyone in here is like that. All right, so hold on, gotta add the notes. This is this one. All right, so the people watching the video, pause it so you can actually take this down. All right, position over time. Explain. So in your descriptions that we were just trying to get you to start listing things out of what it is, all 4 of them. You are going to do all 4 right now. You can work with the people at your group. So 1, 2, 3, and 4. I'm going to call on people to give me some information about these segments of the graph. And go. Anything else you can put on there? I'm trying to get as much information. So you're right on all of this. Get as much information as you can. You're on the way. Okay. Sorry, I was looking at because yeah, 4 things. So just subscribe on all 4. All right, let's go through here. So 1, we will go with number 1, the first one. All right, Jackie, tell me what you know about 1. What's going up? The line, but what does the line really represent? Okay, on those last ones, what did I say that graph represents? And position over time is what? Roberto, what is position over time? Velocity. So if you don't know that, then you should probably do what? Write it down, highlight it, underline it, put little hearts around it. Because these are velocity graphs. Position over time is velocity. So you say number 1, it's going up. So explain it to me in mathematical words. So you can't just say it's going up. It says, what is this is? What is this? That represents a what? That's the what? It's linear. Good. That's another thing. That's not the one I was looking for. So if it is linear, that means it's a straight line, and if it's a straight line, it has what? Roberto, this graph represents the what? Say it again? Because I don't think she's hearing it, because I've asked for it like 3 times and she's still not getting it. So this is the graph of the? It's a graph of the? So you need, every time I say position over time, that is the? So I'm describing the? So the velocity is going where? Increasing. So that means it is? This is positive. I have a positive velocity, right? It's increasing. So increasing, positive velocity. All right, you ready, Jackie? You're not off the hook yet. You said it was a straight line.
Yeah.
So if it's a straight line, it is a just constant what? Constant what?
Oh my god.
Constant what? Roberto, what's the word? So it's almost like we keep trying to get you to say the word that we're talking about here. This whole thing has to do with what? So quite often, when I ask her what this is, you would say it's the. Thank you. So I have a constant what? I have a constant velocity. All right. Now, so I'm not letting go yet. You ready? So the velocity is the change in position over time. Now, make a little triangle out of it. You ready? Because rise over run, position over time. How much is it rising from here to here? How much is it? It's going up 60, right? Good. So it's going up 60 over time. How much time is passing from there to there? 10. So my slope of this line is going to be 6 what? Units.
Oh, meters per second.
Thank you. All right. Meters per second. And this represents my what?
Velocity.
Thank you. Anna, you get 2. It's constant. Very good. It is constant, so it's a straight line, right? So you said no acceleration, so I'll agree with that. And straight line. If it's a horizontal line, what do we know about the slope? It's what? Yes, it is. So my slope equals 0. So that means that it is my velocity is 0 meters per second. That's it. All right. Let's see. Let's see if I say it right. Markle. Did I say it right? Merkel. Markel. I'm trying. Here. All right, Markel. You ready? You get 3. What can you tell me about 3? This one right here. So this 3, you get that one right there. I don't, okay, what's the acceleration? Oh, okay, so don't, you're thinking of it as, it's not, but this is a graph of the, what, Jackie? Graph of the velocity. You could read the acceleration from that, but this is a graph of the velocity. So that means that my velocity is going.
Down.
I have a negative velocity, right? Okay. What else can you tell me? Shape of the line.
Straight.
It's a straight line. So what do we know about? If it's a straight line, what is constant? Yeah. See what I did there? See what I did there? Like psych you out. Constant velocity. Constant, right? And what else? No, it's actually not going to be zero. Something is zero. If it's a constant velocity, then acceleration equals zero. So, and I'll show you as soon as we finish this last part here. Okay? All right, so now we're going to find the slope of this. It's the change in position over time. What is the change in position right here? No, position. So it's actually this way. Remember this, the y value over here is my position. So it's rise over run. So it's going from here all the way down to right here. Yeah, together. So what's the fold? Because right here it goes 60 there, and it goes into the negative there, right? So this whole unit, if each one of these is 20, it goes 20, 40, 60, 80, 100, right? But which way is it going? It's going down. So how do I represent that it's going down 100? Yeah, very good. So we're going to have a negative over time. Now, let's look. Time is going to be right here to right here. Every box represents how much? Look at time. Every box is going to be, yeah. All right, so we're starting right here at 15, right? So that's going to be, no, count how many we're going over. All right, now, no. You ready? You're getting flustered right here. So watch. So every box represents how many seconds? 5 seconds. You ready? So now we're going to count over boxes. So each box is how many seconds? All right, so count with me. So it's going to be 5. There we go. So that's how we read it from a graph. That's how I read it from the graph. It's 25. And it is kind of hard to see in the slides. So, all right, are you understanding now? Yeah, it was just probably the way I was asking. So from right here, rise over run. So I have negative 100 over 25. Can I do the math on that one? What is negative 100 over 25 going to give me? Negative 4. Negative 4 what? Meters per second. Now, you ready, Mark? Mark Pell? Got it right? Okay. All right, so if it's a straight line, right here, it's a straight line, my slope is always going to be that. So right here, as I put my finger, what's the slope right there? You don't have to count it. It's right there on the board. -4, right? So right here, the slope is -4. Slope is? Slope is? Slope is? All right, so now my slope of this, it's a straight line, is constant. So it's always going to be -4. Does that make sense? Now, I gotta get my truck out for this. Did I already? Oh, where's truck? Here's truck. Okay, ready? So he's going -4, -4, -4, -4, -4, -4. Watch. -4, -4, -4, -4, -4, -4. His speed is constant. Is he slowing down? Is he speeding up? So his acceleration is 0. He's not accelerating. So when my speed is constant, the acceleration is 0 because I'm not changing speeds. Does that make better sense? A little bit? All right, hopefully I don't. All right, so 4. 4, 4, 4, 4, 4, 4, 4. Tell me about 4. You could use the information that we just did for these ones right here. Start with something. It's what? I almost heard you. It stops? Yeah, it does. Now, we're just talking about the segment from here to here. This is a graph of the, a little bit louder. Velocity. Okay, it's a graph of the velocity. And my velocity is going which way? It's going up. So I could say that my velocity, if it's going up, is positive. Okay. I'm going to say my velocity, if it's going up, it's positive. Okay. What else could I say? What is constant? It's a straight line, right? Okay. So it's a straight line. So if it's a straight line, it is a constant velocity, right? It's a constant velocity. And if it's a constant velocity, what do we know about acceleration? It's going to be 0. So when it's a constant velocity, my acceleration is 0 because I'm staying the same speed the whole time. I'm not accelerating. I'm not decelerating. Okay, so now let's do the math. We're going to find the slope, and the slope is my velocity. What is the rise? So from this point here to this point right here, my rise is how much? I almost heard you. 40, very good. So it's going to be over time. My time is going to be each one of these squares is how much? Each one is 5. So count with me. So together that is count by fives. All right, so count by five. So 5. So 10, 15, right? 15. Yeah, it is going to be 15. So I get 40 over 15, which comes out to be 2.6 repeating, and my units on this one's going to be very good, meters per second. All right, are we okay still? Nacho's shaking his head. Why? Is it a Monday thing? Okay. All right, so now we're going to actually talk about a different graph. This is a graph of acceleration, which is the change in velocity over time. Because velocity is position over time, acceleration is the change in velocity over time. And I know we're all writing this down because this is some good stuff right here. And let me put this in here. I know we're filling this in. Okay, the rise is going to be my change in velocity over the change in time, and the slope represents the average acceleration. So just so you know, this is probably one of the harder concepts to try and understand because picking things from a graph, it's not easy. And even my calculus students had trouble with it with just looking at it from graphs because you have to read what it specifically represents. Alrighty, so you must be able to calculate the acceleration from a graph. I would like for you people right now to try this. I just did this on the previous graph where I've shown you how to find the slope. Now, do that here for the intervals that it's giving you. And go. Is there no sanitizer? I'm gonna try and ask for some. Ooh, look at you. You are prepared. Quite possibly. Yeah, I'll ask you for the second one. What? You said you wanted the second one. So we're all trying to math this right now, not zoning out. We're mathing this. Doing the slopes that I gave you, I showed you how to pick it off. starting to like. Starting like this. No, that one's going to be the next one. So. Here it's going to. Alrighty then. Let's see what we got here. Let's see what we got here. So for number one, or the first one, from 1 to 5, what do we get? I can't just shrug my shoulders and call it a day because my teacher's just going to keep picking on me for the same problem. How do we find it? Looking at other people's papers don't count. How do we find it? You ready? Hey, up here. We're going from where to where? From 1 to 5. So 1 and 5 is here. What is my rise? It goes up 2. So I'm going to say it goes up 2. And I lost my marker. Can I leave my marker over there? Hope not. So it goes up 2. Over. Count. How many does it go over? Try again. Okay, so we're counting. So it's and the run is. So what do we end up having? One over 2. As the decimal is going to be 0.5. What are my units? This is the acceleration, though. Come on now. Units are what? Don't shrug your shoulders at me. What are my units for acceleration? Close. Squared. Thank you. All right. Can I help you out later on? All right, next one. Let's see, from 14 to 19. 14 is here. 19 is here. What is the rise from 14 to 19? Jackie? What? You weren't here, so I have to pick on you even more. I gotta make up for lost time. From 14 to 19, what is the rise? So what is the value at 14? Okay, what is the value at 19? It's -2. Okay, so if it's -2 here,
0.
thank you. The rise is 0. So there's no change. So the rise is 0 over my time. Count it out for me, Jackie.
1, 2, 3, 4, 5.
So that's going to give me. What's that going to give me?
0.5.
0 divided by 5. You have 0 pizzas and you're dividing it equally among 5 people. Each person gets 0. What are my units? Because it's acceleration. And for the last one, I'll help you out. This one's actually going down to over 2. Down to over 2. So it's -2 over 2, which is a -1 meters per second squared. And please make sure you like, share, and subscribe. Why?